Okay, so this is prerequisites number 9, and what we're doing are piecewise functions. So, what we're going to start with is question 1. An electrician charges $250 per hour for the first hour of work and $75 for each additional hour. So, $250 for the first hour and then $75 for each additional hour. So, we're going to generalize a piecewise function. And so what this means is that with our piecewise function, so when we talk about piecewise functions, this is going to be a bracket, and then we're going to have an equation here, and then we're going to have, typically it's a range, so if it's like x is less than something, and then it's also greater than something, and then we'll have another equation, and then maybe it's just x is greater than these values here. You could have more than 2 functions, you have 3 equations, 4 equations, but it's always going to be in the format where we have a bracket and then more than 1 equation. So that's all it means when it says piecewise. So for piecewise for this, let's start with our bracket. And then it says that our electrician charges $250. So what I like to do is, since we're talking about C, and it's the cost or charge, because we're talking about charge, so that's what our C is. Technically, that's what you could call our Y as well. So our X value, we're going to say, so it's each additional hour. So we're going to say H for hours. So we are going to generate a piecewise function to determine the cost. The cost works by, we're going to say C is equal to, so $250 for the first hour. So that means that we're going to say C is equal to 250. And how this works is that we're going to say it's for the first hour. So the first hour up into the first hour, we'll say H is less than 1. Since it's the first hour, it's including the first hour. So if H is 1, it's including that. And this is going to be up until the first hour, so it's all the values from 0 to 1. And then we're going to include 0 in this. So it's 0 if it's 0 hours, all the way up until if it's 1 hour. The second equation we have, we're going to say C is equal to, so we have $250 for the first hour, so we can say 250 plus $75 for each additional hour. So it's going to be plus 75 times H. And that's going to be when our hours are greater than 1 and not equal to, because we already said that equal to is in our first spot. So now that we have our 2 equations, what I want to note is that for our hours, they're additional hours. So when we write our equation, we need to change our H to be, what we're going to do is H, and then we're going to do minus 1. And that's our hours minus 1. So say we work 2 hours, we do 2 minus 1 to get 1. That's the additional hour that we worked. And you'll see what I mean once we graph it. So how this works is, we're going to make our graph now. And how we make our graph, we want to first start by labeling. So we're going to label our x-axis, that's our H. Those are the hours. And then over here, our y-axis is going to be the cost. So C and H. And remember, when we draw axes, we want to make sure we draw arrows to show it's going on infinite. So let's label our hours first. So I'm just going to label every 2 boxes. That's a good enough scale. We're going to go up, let's do 6. For our cost, what we're going to do is, instead of drawing a straight line the entire time, we're going to draw a straight line down until about here. And then we're going to do something called a break. And when we break our graph, what this is representing, if you've never seen this break before, all it represents is that we're not going to start our data on our y-axis at 0. We're going to start it at some other number that we choose. And so what I'm going to do is I'm going to choose 250 for our break. So this is 250. And so all that means is that when I choose our next value that we go up, and let's go up by 75, so 325, is that we didn't have to go up from 0 to 75 here. That's not an accurate scale. So when we do this break over here, the break is saying that the data in between 0 and 250 doesn't exist. We don't need this data. So we are just going to have the break and start at the important data. Also, so that when we are making our graph, and our graph looks like this, our data would start up here and keep going. So with our break, we just have a more finite set of data. You don't have to do a break, but I think the breaks just show the tinier details in our data better. So let's finish our scale. So we have 325. Since we're going up by 75, we go to 400, 475, and then let's stop at about 550. Okay, so let's go back to our piecewise function. Our first part of our piecewise function is 250, and the 250 is from 0 to 1. So when we have 0, it's at 250. When it goes from 0 to 1, it's still at 250. All these data points are 250. That's all that the first equation means. That's it. The second equation, though, is a bit different. So our second equation is when our hours are greater than 1. So it's not including 1, but it has to be greater than. So what that means is that if we put in our at 1, so let's try what it looks like at 1. So if we do 250 plus 75, and remember we did h minus 1 for our hours. So when we put in our 1 minus 1, we get 0. So 75 times 0. And that just turns out to be 250 plus 0, or just 250. So we get at 1 that it's 250, and as we can see with our original value, it's also 250. But remember, when we plot points at a less than sign or a greater than sign, we have to do an open dot because it's not equal to. So let's try another point. Let's try 2. So if we put in 2, C is equal to 250 plus 75, 2 minus 1, we get 250 plus 75 times 1, or this comes out to 250 plus 75, which is 325. So then at 2, we get 325. So that's our next point, and we can connect it. So let's do C, let's skip C equals 3, and let's do C is equal to 250 plus 75. Let's do our H is 4. So 4 minus 1, we get 250 plus 75 times 3, or 75 times 3 plus 250 is 475. Or if we see, it's our point over here. And so when we connect it, we can infer that our third point is going to be 400. And we know when we can do the math and we can check, and it will be 400. So as we notice our rise, we go up 2 and our run is 2. So technically we're going up 75 and then we're going over 2. So let's go up 75 over 2. That's our next point. Up 75 over 2. That's our next point. And we can write an arrow at the end to show that it keeps going on. So this is what our graph looks like. This is the graph of our piecewise function. And we can see that this point that I have in green here, this point here is important because it's showing that the first hour is a set price, and then after that, it increases. Okay, so now let's move on to question 2. Question 2 says to find each of the following values, given that f of x is this piecewise function. So all we're doing is we're plugging in the value of x that we're given. So x is -6, x is 1, x is 6, x is 0. So let's start with A. When is x equal to -6? Well, we have x is less than -6. That's not greater than, that's not equal to, so that doesn't work. -6 is less than or equal to x, which is less than 1. Well, we have our -6 here, and it's less than or equal to, so we know that this is going to work. So we're going to use the equation 2x plus 7. So when we plug in our x as -6 plus our 7, we get 2 times -6, which is -12, plus 7, or we get -5. So the way we write that is f of -6 is equal to -5. The next equation we have is 1. So when do we have our f is 1? Well, let's look. X is less than -6. Nope, that doesn't work. -6 is less than or equal to x, which is less than 1. It's not equal to, so that doesn't work. X is greater than or equal to 1, so we know this works. So we're going to be using the equation x over x squared plus 2. So every time we see x, we plug in 1. So 1 over 1 squared plus 2 becomes 1 over 1 plus 2, or 1 over 3. So f of 1 is 1/3. Next, what we can do is we have our f of 6. So x is less than -6, that doesn't work. X is between -6 and 1, that doesn't work. X is greater than or equal to 1. This one works. So we're going to be using the equation x over x squared plus 2, or 6 over 6 squared plus 2, which becomes 6 over 6 times 6 is 36 plus 2, or 6 over 38. 6 over 38 simplifies to 3 over 19, or f of 6 is equal to 3 over 19. The last equation we have, we're going to be using the point f of 0. So when does f of 0 work? X is less than -6. Nope. X is between -6 and 1. Yep. So we're going to be using 2x plus 7. So 2 times 0 plus 7. 0 plus 7 is equal to 0. So f of 0 is equal to 7. Sorry about that. 0 plus 7 is equal to 7. So f of 0 is 7. And so see how we didn't use our x cubed equation at all for any of these values? Because we weren't given a value that fits with that. So sometimes they might ask you for piecewise functions and they won't ask you to use every single equation, or you won't have to use every single equation. Okay, so let's go to 3. So we're going to rewrite 3x plus 2, the absolute value of 3x plus 2, as a piecewise function. So when we do this, if you remember absolute value graphs, absolute value, so say the absolute value of x, it's a v. So roughly the absolute value of 3x plus 2, it's going to look something like this. So it's still a v. So we know that the change in our function is probably going to be over here when x is 0. And we can try a couple of different examples to see. So let's see what happens when x is 0. Well, we get the absolute value of 3 times 0 plus 2, or, and remember it's g of x. So our g of x is 2. Okay. Let's try when x is -1. Well, when x is -1, we have the absolute value of 3 times -1 plus 2. So our g of x is equal to 3 times -1 negative 3 plus 2, which is equal to 3 plus 2, or 5. So we have 0, 2, and the next one we have is negative 1, 5. So now let's see what it looks like at positive 1. Do you think it's going to be the same thing? We get 3 times 1 plus 2. The absolute value of 3 times 1 is the absolute value of 3 plus 2, or 3 plus 2, which is 5. So even with 1, we still get 5. So that's why we know that our change is going to be at 0. So when we do our piecewise function, we can have an x is greater than 0, and then an x is less than 0. Now, the main thing that we need to include before we write our equations is that we have to include x has to equal 0 somewhere. You can put it on either one. It could be greater than or equal to 0, or you can put it on the less than or equal to 0, but it has to be one. It can't be both. So I'm just going to write it for the greater than or equal to 0. It doesn't have to be that. It could also be the less than or equal to 0. This would still work. So we're going to write that g of x is equal to, and so we have our 3x plus 2. So let's think about it for a second. We can write for both of these 3x plus 2, but there's something that's missing. So think for a second, we're missing one small thing. If you need help, let's look at these two lines here. This line is 3x plus 2. What do you think this line is? This line is negative 3x plus 2. So one of these equations have to be negative 3x plus 2. And we know which one it is because the values of x have to be less than 0. X has to be less than 0 because we're going to the left of the x-axis. So when is x less than 0? Over here. So it's negative. So our piecewise function is this over here. And that's it. That's the piecewise function. So we finished piecewise function review number 9. So let's go on to number 10. So a certain bacteria population sample contains 500 bacteria and is known to grow by 20% every hour when left untreated. So write an equation to model the untreated bacteria population Y after X hours. So Y after X hours, we are going to be writing in the format Y is equal to A times B to the X. So hopefully you've seen this before. If you haven't, all this means is that our A is our y-intercept when our x is 0. That's what our y-intercept means. And then our B is our factor, or basically what we're going to be multiplying by. That's all that means. So we're going to write an equation to model the bacteria Y after X hours. So what this looks like is that, remember, our bacteria contains 500 bacteria and is known to grow by 20% every hour when left untreated. So that means that the initial, or our y-intercept, is 500. And remember down here, I said our y-intercept, that's A. So A is 500. And then our factor, our B, that we're going to be multiplying by, so B, it's growing, so the keyword is growing by 20%. So the way we write 20% is 0.2. But when we multiply a number by a decimal that's less than 1, it's going to decrease. So when we are growing, we have to add 1 to it so that it increases. So when we put the 1 with it, the bacteria is actually going to be growing by 1.2. So what this looks like is our population Y is equal to 500, our A, times 1 plus 0.2 to the X. And we just simplify that by writing y is equal to 500 times 1.2 to the x. So how many bacteria are in the sample after 5 hours? And then 7.5 hours. So in 5 hours, we just plug in 5. 500 times 1.2 to the 5th power. And what do we get when you put that in your calculator? Y is equal to 1,244. And our units are bacteria. So if we're going to do 7.5 hours, we do y is equal to 500 times 1.2 to the 7.5. And when you put that into your calculator, you should get 1,962 bacteria. And this is after 7.5 hours. And that's it. That's our prerequisite number 10. That's pretty straightforward. Okay, so now we're going to go on to prerequisite number 11. Prerequisite number 11 are exponent rules. So this one, again, is just pretty straightforward. It's just if you know the rules, then you know the answer. If you don't know the rules, then you need to study, because these are, you just have to know the rules. So when we have an exponent and we have it in our parentheses, we multiply it. So what this looks like is w to the 0 times -1 times x to the 5th times -1. Anything to the 0, 0 times anything is just 0, and then we have x times -5. So remember, any number to the 0 power is 1. And then our x to the 5th, remember when it's a negative power, we put it over in the denominator of a fraction. So this just becomes 1 over x to the 5th. Going on to 2, we have c to the -3 times c to the 7 to the 4th. So we're just going to keep c as -3 for now. But remember, we're multiplying our exponents in the brackets. So this becomes c to the 7th times 4, c to the -3 times c to the 7 times 4, which is 28. Now, when we have our exponents, when we're multiplying like this and we have our exponents, we just add the exponents. So c to the -3 plus 28. There's no brackets, so we add the exponents. C to the -3 plus 28, c to the 25th power. So, 3. This one's long, but it's not too tricky. So again, we're going to be multiplying by these two exponents. So u to the 3 times 2, v to the 5 times 2. And then we still have these, u to the -7, v to the -10. So let's simplify the left side first. U to the 3 times 2, or u to the 6, v to the 5 times 2, or v to the 10. Then let's bring down our other side, u to the -7, v to the -10. So now let's multiply our terms together. Let's do u and u first. So u to the 6 times u to the 7, or 6 minus 7. Then we have v to the 10, and then minus v to the 10, or the 10th. So u to the 6, 7 becomes u to the -1, and then v to the 10 minus 10, or 0. So remember how I said before, how anything over the negative exponent becomes 1 over the exponent, and then anything to the 0 power just becomes 1. So our final answer is 1 over u. The last one. It's a lot, but once we combine the numbers, it isn't too much. So what this looks like is, let's start with our x's. So we have an x here, and we have an x here. So remember the rule, whenever we have a number over itself, we subtract the fraction. So this would look like x to the third minus the fifth. And we can do that because remember, 1 over x to the fifth is actually just equal to x to the negative 5. So when we combine the fractions, it looks like this. So the first part we get is x to the 3 minus 5. The second part, let's work on our y's. Y to the fourth and y to the negative 3. And remember, this is being multiplied by. So we'll just do y to the fourth minus 3. Let's work on our z's now. Z to the negative 2, z squared. So let's write it over our fraction. Z to the negative 2 plus 2. The last one we have is w. W to the fourth over w to the 7. And remember how I said for our x values, we subtract the 7. So now to simplify, x to the 3 minus 5 becomes x to the negative 2 times y to the 4 minus 3, or just 1, times w to the 4 minus 7, or negative 3, all over z to the negative 2 plus 2, or 0. So to simplify this, x to the negative 2 we're going to put in the denominator. So we get x to the positive 2. Y to the 1 is just y. W to the negative 3 we're going to put in the denominator. So we get w to the positive 3. And then z to the 0 is just 1. So we just leave it like this. And this is our final answer. So these are exponent rules. And again, these are something that you just have to know. It takes practice, but you need to just work with these, do some practice, and then you'll get comfortable with these. So the next video, we're going to finish up. We're going to do 12 and 13, and that'll be the end of the series.